Okay. Hello, I'm Falco, and I want to talk a little bit about my little side project, the simple bike computer, because I wanted to do something useful with Bluetooth Low Energy as a geek. This presentation is actually a markdown, so if you don't believe me, it is. So if you find any errors, don't tell me. Start a pull request on GitHub. We might actually be able to accept the pull request during the presentation, and you will see the update right away. This is possible with this nice app. It's only available on a Mac, but I don't know. Anywho, about me. I'm a Seabase member as well. I'm at Volker's Fund on Twitter, mobile software developer, and I think this domain is correct. I don't know. So what I want to talk about. I first want to give you a small introduction. What is Bluetooth Low Energy and like the things you need to know, some terms you should know. How does it work on Android? What's my simple bike computer? What do you need as a hardware setup? This is why there's a bike. What do you need on your phone? And maybe, if we have time, if you guys don't throw tomatoes, we'll look on to other platforms and see what we can do with other platforms, because it's quite similar. So what's BTLE? Bluetooth Low Energy. It's also called Bluetooth Smart to some people. I don't know. But everyone is in this room will call it Bluetooth Low Energy. It's a protocol for simple low energy data transfer. You can send small bytes of data really fast. It's not really made for big chunks of data. Like I said, you don't want to send a lot of data, and it supposedly has an easy binding opposed to the old Bluetooth standards. This is some. Is that readable still? Almost. I mean, we can switch the theme. Is this better? Better, right? See? Backset was awesome. This is some talk from the website. Whatever they thought Bluetooth Low Energy is supposed to be. They also call it Smart Ready. So I don't know if you ever buy something that is Smart Ready. It's basically also Bluetooth Low Energy capable. I don't know why they call it Ready, because it's fully capable. It's not like HD Ready, which wasn't HD. So don't get that confused. So whenever something is Bluetooth Smart or Smart Ready, you're good. You can use it. On Android, if you have a device with Android 4.3, then it should natively be supported by the operating system. If your device has the necessary hardware, which most of the devices that have support for 4.3 actually have. And you can get, like any new device you probably buy today has all this. Let's talk about some terms. There's services. So services are a collection of characteristics. We'll talk about characteristic next. So basically it's a collection of things that are called characteristics. And the ones I talk about today, they're all standards. And I also link to the standards. It's actually quite interesting. It was the first time for me to really read standards and follow them, and it worked, so it's kind of cool. Then we have characteristics. So one characteristic defines one attribute. So let's say your device, like this bike sensor you can see here. This one, yes. It has one characteristic called total crank revolutions, which is the times the pedal was turned. So that's one characteristic. And it also has another one, which is the total wheel revolutions. So it's like one piece of information associated with one device. Then we have descriptors. They describe one of the characteristics. The only time I really had to use them is on Android when I had to subscribe to a value, but maybe we'll look at this later. Okay, so we had services, descriptors, and characteristics. Very basic things. So there's characteristics in a service, and you can have multiple services. So why do I want to have a bike computer? Of course, I ride my bike. The bike computer use case isn't too expensive. This piece of equipment was like 40 euros. My colleague Yuri has one, which is this. It was like 30. So they're pretty cheap. And I have one question I ask myself, like how far do I go? How fast do I go? And I also ask myself, like on a weekend I did a lot of biking, or I accidentally did a lot of biking, and at the end of the weekend I was like, damn, I want to know how many kilometers I went on that weekend. So I thought, how cool would it be if my phone would connect to my bike, and every morning read out how far I went in the morning, and every evening when I disconnect, or at the next morning, it would read out the next kilometers I did. And then tell me, on a Saturday you did 60 kilometers. And I was like, yeah, I want that. And also it's healthy and stuff, and health stuff is cool now, so that's always good. So having computers tell you how active you are is always good, so why not do that as well? So what do you need? Speaking of hardware, so I choose this piece of hardware, and the term is speed and cadence, and you see it has an arm. So there's one sensor in the main part and another piece of sensor equipment in this part. There's two magnets, and if you come closer at the end of the presentation, you will see the same setup on my bike. What you can't see is the labeling, because I thought if I put this thing on my bike that says Runtastic, everyone would be like, ooh, Runtastic, it must be pricey. So I took nail polish and removed the labeling, so nobody can see it. Sneaky me. And this is the other device that Yuri has, the one on the left, which is a little different. It has a little cord connecting the two sensors. And as you can see on the right, there's also the same sensor by another company, but it's probably the same factory in China making it with another label. But it's like totally identical. And also, if it says speed and cadence, that's a standard. So you can, unless they're doing something really bad, you can really pretty much assure that it will work. So this is what you need. If you guys want to buy this stuff now on Amazon, go to and search for these terms. Don't really use it on a Nexus 4 because Bluetooth Low Energy is broken there. And I would recommend like disguising the hardware. Take off the labeling with nail polish remover. It works quite nice. So let's talk about this speed and cadence, whatever that means. It's an official profile, and let's see. Yes, nice. So we can actually go here and look at it. If you want to see all the profiles that are there in the world, and this is what I talked about, the specification, you can find all of these here. So you can find the glucose measurement Bluetooth low energy profile, and you can read all about it, and you can start implementing your own glucose meter connector. And I don't know, any other things. So speed and cadence is here. So I choose to implement org.bluetooth.service.cycling speed and cadence, which consists of two parts, which is the speed and cadence service, again, a service, so a collection of characteristics that specify the speed and cadence. Cadence is the amount of pedal movement. So my app at the end should tell you you're pedaling with 90 revolutions per minute at a certain speed. So these two things are contained in that specification. And then there's a generic service specification called device information, which encapsulates like firmware revision and software revision and manufacturer names, stuff like that. So you will find this piece this service in multiple hardware that's on the market, and the cycling speed obviously only with your cycling speed hardware. So maybe we can look at it and try to understand it a little bit. Again, I told you it's this cycling speed. It has a name, and it consists of two services. And one service is identified by a number. We'll see that later. And it has a couple of GUT requirements, error codes, all that stuff. For instance, it contains the actual measurement as a characteristic, which is this, the measurement. And you can read all kinds of stuff. And actually this specification is an XML file. So in theory, if you have your own Bluetooth Low Energy device, you should be able to specify it in this XML format. And this website should be able to render your specification in a human-readable way. Okay, what do we do on Android? Again, Android 4.3. In Android 4.3, you can get the Bluetooth manager. You can scan for devices and then connect to a GUT callback. GUT is the general attribute. What T? I don't know. What's the second T? So this is the services and characteristics are all GUT things. So a GUT callback has all kinds of callbacks methods. You can get notified when your connection state has changed, when the RSSI, so the signal strength, has changed. You need to discover services. So you need to ask your device what services it provides. And then in this case, we want to subscribe to one of these characteristics, to the actual measurement characteristic, and react on the changes there. So we'll be implementing onCharacteristic changed. Yes. Okay. So what do we do to get this bike-computer working on Android? We need to subscribe to the notify characteristic org.bluetooth.characteristic.csc measurement, which is this piece of this characteristic 2A5B, which is binary and has some fields, and we can look at it later. So we need to subscribe to this characteristic. We need to extract the values because it only gives you a byte array of things, and then we need to display them. And what I also did, just for monitoring purposes, I wanted to get updated on the signal strengths, so to get some kind of idea of the connection, if it's stable or not. So, and now we'll start the code part, and you don't need to write it down. Again, it's all in the markdown. So we start with and this code is all you need. So it's actually pretty easy, and maybe Nietzsche can tell us, but regular Bluetooth is a lot more complicated and hassle. Is it? No? Anyways, so we start a scan, and what you can do, you can specify the services that a device should advertise. So you don't need to scan for all the devices, you just want to scan for the devices that offer this specific service that we're interested in. And if we get a scan callback, we start to connect to the GUT. And what's important here, actually this should be a true, because on Android there's an option auto-connect, and you really want to have that true, because it's like occasionally it will drop the connection and reconnect. So you want to tell the system that it should auto-connect. And then you hand over your own Bluetooth GUT callback, which is a class that I just mentioned, which gives you callback methods on the connection state and all these kinds of things. So in our Bluetooth GUT callback, at some point we'll get a state connected callback, and then we can start to discover the services. Fun note, through work we actually had some hardware that at some point gave us an unknown status. So this is an integer internally, and it didn't give us any of the documented stati. but 113. And it was really hard to find out. The 113 was actually to be found in some C header deep in the blue droid, or I don't know, like deep down in the drivers, basically. And for some reason, the whole stack sent me and the definition of 113 was failure. So really weird. But by this you can tell that the whole stack is not really stable, or you can have funny things happening, so you should be aware of weird things happening. But again, back to topic. We want to discover the services because we would like to identify that this hardware that is advertising some service that we're interested in is really providing this service. So on service discover, is this readable? Yes. We will find our specific service, we will get the specific characteristic that we're interested in, and this is where first thing that is kind of weird starts. You can directly say that you want to be notified on this characteristic through the Android API, which is the first 2 lines, but that's not enough. I need to also modify the descriptor. This is just something to remember. What? Louder? Ooh, better? It's falling down. I don't know. Ooh. Ooh. Okay. Good. So now that we told the system that we want to get notified. Oh. Thank you. Thank you. Test. 1, 2, 3. Good. Yes? No? People in the back? Can you hear me? No. Okay. I'll do it like this. So on characteristic changed will be called, and then we can go and extract the values. And what I also did, every time on characteristic changed is called, I tell the system to read the signal strength, so I can get an update on this. There's no, like, you can start a timer or anything, but this is what I did. And that's it. Like at this point, you'll get updated on this characteristic, and it'll just work. So if you like, the first indication on how good the connection probably will be is in the scan callback. So you can also get the signal strength here. And okay, so to really show that it will work, I actually did an app for this wearable, also for a heartbeat sensor, which is basically the same thing but not so difficult. But we'll get to this later. I also built a simulator on my Mac. So on my Mac, I'm simulating this heartbeat sensor because I didn't want to rely on my heartbeat sensor on my chest all the time. So as you can see, it worked at least once, and maybe we'll see a working solution today as well. Okay. So this was the part where, like the bike computer part, where I want to get notified about values on my bike. And now it starts to get interesting. Like maybe I want to also read and, oh yes, questions here.
What happens if there are 2 bike computers in range?
Well, currently my implementation takes the first one. Of course you can, like this whole project is still at the beginning, and I'll obviously eventually want to remember the last bike computer I was connected to and connect to this one specifically. But I guess this is not the tricky part, to remember a MAC address and then just directly connect to this. If you have any questions at any time, just ask, please. You? Okay. So the question, anyone, I should repeat the question. So the question initially was, what if there is 2 bike computers? Or another computer simulating a bike computer. So that should also be possible. So what you also want to do with Bluetooth Low Energy is read characteristics that don't change. and also write things to a characteristic, which is also possible. So there's different kinds of characteristic: read, write, notify, and maybe another type. But you probably want to read and write. The problem is, which we found, the whole read and write is very asynchronous. So you write to a characteristic, then you get a callback that a write was successful, and you don't really want to schedule multiple writes. So I extracted some classes that we had at work, improved them a bit, and also put them in the project. They have never been tested, so they're not really production ready, but in general I wanted to extract the read and write asynchronous interface to give you a synchronous interface and an easy command queue and stuff. So that eventually your read and write will look like this. You specify your read commands and then fire them off, and then you eventually get notified that they have been successful or not. If you don't do this, you would have to eventually make sure that all your read commands or write commands have been successful. And something that is also not possible if you take the default, like if you read something, a characteristic, write, and then read again, basically when you read, the value of the write will be overwritten, because there's like you need to manually set the value of the characteristic, and then with every read it will be overwritten, which is kind of weird. So if you really want to use it, I would say there is some abstraction necessary, and this is also part of my project. As you can see here, this stuff should work. Like I had a button and it should actually read out these manufacturer data and then print it to the log, but I have really no idea if this really works. And all the other code is also taken from the project. I tried to like abstract all the things away a little bit so they are nice and clean. So if we look at this Bluetooth package here, like we have a speed and cadence connector, and as you can see I have the speed and cadence service UUID and the characteristic UUID, and eventually on-characteristic change will be called, and you can actually see how I extract the actual values from the byte array, which is not really hard. This was when I understood little and big endianness for the first time. And then at some point I guess I tell my listener that the speed has changed. And you can do the same thing for the revelations of the crank. So it's pretty straightforward, and I abstracted this notify connector, which basically is in charge of connecting to a peripheral, then scan for the services, connect, and give you a clean callback on the actual data. So that's all contained in here. You want to see the notify connector, same thing going on here. Let's see. So we do a scan. We scan for the devices. When we found it, we connect to the gut. At some point, when we have the right connection state, here we discover the services. Everything you just saw in the presentation, just a little bigger and stuff. All right. So also one really cool thing about this project, since the Android Wear I'm wearing also has Bluetooth Low Energy, I thought how cool would it be if I write an app that directly connects my phone to the watch, and these classes are ready to do so. So I've just been using the same classes there. And as you've seen in the video, it should work. Yes?
You mean the watch to the...
Do you mean you want to connect the watch to the bike?
Yes, I want to connect the watch to the bike, because when I'm biking, I can see my watch, but I can't see my phone. There's again, actually the sample for the watch is now bigger than the phone sample. And the cool thing is you don't need a host app, so it's a really unique case for Android Wear where you don't need a host app. Usually with Wear use cases, you need some sort of app on the host. And with this use case, even like eventually, I want to sync the data from the phone from the watch to the phone, and not vice versa. So pretty cool actually, and I can go biking with my watch only. Yeah. So this is the bike computer I'm building, and you're happy. I invite you all to look at it and start pull requests. The generic stuff I pulled into a separate module in this Gradle project. So hopefully you could use these classes as well. They will improve over time, obviously, but this is what I'm doing at the moment. I also want to write a service that auto connects to the bike eventually. Hopefully this will also work on the phone. And the presentation I'm holding is on the second URL. Again, it's Markdown, so you can just use it. So, and I'm also doing like iOS or macOS development because it's fun. So I also looked how this is done in Swift, the new Apple development language. Everything is a little easier, I have to say. The code there, which is really cool, the same code runs on a phone or on a Mac, which is actually a lot of fun. So I'm able to connect my Mac to my bike and see the speed and the crank beats per minute there. Which I'll probably never do right around my bike with a Mac connected to it, but like for debugging purposes at the beginning was fun. I can just disconnect the sensor and rub it with a magnet on it and see if my code actually works. What is really cool and what I'm planning to like do a little more is to simulate the bike computer with my Mac, because I don't want to have this thing, this device with me all the time and rub magnets to it. And so I thought, why don't I have my Mac become the bike computer, and I don't need to, and I can actually have the bike computer permanently attached to my bike. And this is not all the code, but basically it. So on a Mac, if you have one, you can check out this project as well. You declare the services, you declare the characteristics, start advertising, and then at some point you just update the data. And what you've seen in the video where I iterate the beats per minute on the simulated heartbeat sensor, it's just a timer counting values up, so really easy. And it actually works, so I was able to connect my Mac simulating a heartbeat sensor to my phone, to my watch, and the watch showed me that my pulse was increasing by 1 beat per minute every second. So I don't know, you can probably do funny things with health apps and see if it would actually be interesting, what does Runtastic do if you simulate a pulse of 250? Like, do they automatically call someone? I don't know. Or like, how many calories did you burn when you simulated a run with a permanent pulse of 250? I don't know, that'd probably be fun. And again, also what this code should show you, like if you look here, I know it's Swift and you probably all don't like it, but this is a dictionary, and I'm actually advertising these services as well. So what we've seen on the Android side, where I scan for peripherals that advertise certain services, on the Mac I of course have to specifically advertise these services as well. Otherwise, you would have to connect to a device, scan for the services, find out that the service is not contained by the device, and then disconnect. So you want to advertise what services you are advertising. Also on a Mac or on iOS, if you want to do the same thing as we did on Android, you do pretty much the same thing. You have these Bluetooth UUIDs, which is a little easier to write, because on Android, and if we look at it, it's actually quite funny. It's a UUID, and on the specification we saw that they are all these 4 digits. And at the beginning I was like, how am I going to do this 4-digit UUID on Android? The problem is UUIDs, as you all know, are bigger than 4 digits, but they're prefixed with zeros and suffixed with a fixed string. So I wrote a little helper as well. So this is the suffix you need to add to the 4 digits you find in the specification. My bike is in the way. Okay. And on iOS or on Swift, you have a simple class already that encapsulates this. Again, on Swift or macOS, you have the same principle. Connect. Once you connect, it will discover services. Once it discovers services, discover characteristics. And once you found characteristic, with one line, which is what Android simply tell it to get notified when it changed, and then you get notified. So pretty much the same code. So I would say that this concept of scanning for services is generally Bluetooth, and so the abstraction is pretty much the same. Yep, that's it. We can actually try to have this whole setup working here as well. So I have this Mac running. I can start the heart rate sensor, and let's see. In parallel, we can start this. So this window shows what's happening on this device. Oh, and you can see, wow, demo gods, awesome. So you can actually see that my Mac is currently simulating this characteristic change, counting up the value, and the watch, which is actually lying here, and it's not measuring my heartbeat because I'm not connected to the watch, and it shows the same value. So it is actually working, and hopefully you can tinker around with the whole stuff. I have no idea if you can do all this stuff on Ubuntu or Linux as well, but probably. Questions? Or feedback? Nothing?
I have feedback. Go back to your presentation.
Okay, yes.
To the 4th slide or so.
4th.
Yeah. Or so.
1, 2, 3. This one?
No.
Which one?
One with a link to the Bluetooth profile, the speed and cadence thing.
Yes. Yes.
Yeah, here. Don't
Yes.
click on it.
Okay.
Not sure what it is, if it's the markdown formatting or what, but the underscores are missing. So you have cycling underscore speed underscore and cadence.
Did you do a pull request?
No,
Why not?
I'm not sure how to fix it.
You edit?
I'm just reporting errors here.
Oh God. Is this one? CSC.
No, further up.
This one?
Yeah, this one.
Yeah, but it's correct. It's markdown that's broken.
You use command mark.
I don't know. Italic. Anywho,
Does anyone know how to escape it?
No.
escape.
Can you do that?
You want to escape? There's exits.
I don't know if you want to escape the mark. Try backspace.
Yeah, questions. There's a question.
Yes, I don't know if it's relevant enough. I have a Nexus 4.
You have a Nexus 4, yes?
Connected to 3 devices
Yes.
simultaneously yesterday,
Yes.
I think, and it seemed fine. So it's not always reliable. So what's the problem? Can you point me to some?
Well,
Oh,
he can explain.
Hi. So
I'm working with him in the same company, and Bluetooth Low Energy, I used it with the Nexus 4 previously. The problem with the Nexus 4 is that they saved on the antennas, and Wi-Fi and Bluetooth is going over the same antenna. So if you turn off your Wi-Fi, it will work more reliable. That's the solution. And most of the time they also use the same chip, so it's a simple explanation.
So it's not a matter of software, but it's really...
It's a real hardware issue.
But it's also software, like I'm trying to have this watch, and it's also connecting through Bluetooth Low Energy to my phone. But like, I really have to reboot the whole phone at least once a day to get the connection back. So there must be some problem in the stack.
Multiple issues.
And at work, we found out that the Samsung Bluetooth stack is really more reliable, because I think they've been doing Bluetooth Low Energy on Android with basically their own private APIs since Android 4.0 or something. So they seem to be a little more reliable, but then we all don't like Samsung, so that's not really a solution. But underneath the hood, and as I told you, like I never want to get some C error code up in my Java. Like I never want to have this surface. This should have never happened, but it did. And it's not the first time. If you search for this 113 in Android and Bluetooth, you find multiple people like, what's happening here? You know, so there be dragons. 1,000 what?
133.
133. I'm sorry. That's
100
100.
is also really...
So I don't know, but like if you talk to people working with Bluetooth Low Energy on Android, there's weird things happening. Like probably Dirk can tell you funny stories where they disconnect and connect and then it's fast again or something like that. Right?
Yeah, well, actually solved.
He solved it. Okay. Any other questions?
Question regarding this advertisement, like is it part of the Bluetooth Low Energy specification or for all?
So, okay, maybe to talk about this. So, what you do, the initial step to get a connection, you have to have your device advertise that it exists. It'll use 3 channels and will advertise some bytes of data as part of the advertising packet.
Is the name advertised there also?
I think in the specification, the name can be part of of your advertising, but I don't think it has to be. So you can have advertising with no name, but then again you can put whatever you want in there. And also with the services, you don't have to advertise the services. And like you can have a really short advertising package, and there's a maximum length. And Apple decided to put some UUID in it, and that's what they call iBeacon. So you can basically put any data in there, but it's limited in length. But I guess if you specify how to put the name in there, then, or if there is people doing it, there must be a specific way, because when you scan for devices, they sometimes tell you the name. So I guess there is a way to put it in there, but I don't.
But it's not enforced. Like before, with Free,
Oh,
it was
no,
always
it's-
hard, like because you have to ask every device for the name,
No.
and because you can only ask one device at a time, it kind of takes some time.
Yeah.
But then that could be solved with this advertising.
Yeah, it is.
And then you
It's-
can also use it for free, right? From the device has for.
Basically, Bluetooth 3 is something totally different than Bluetooth 4.0. Like they have nothing in common. They have the same name, they have the same frequencies, but it's totally different. So anything you know about Bluetooth before 4.0, congrats, you're probably a brave person, but it will not help you. And things are really a lot easier here. One thing interesting, which I think is a bug on Android, if you want to connect to a Bluetooth device, Bluetooth, where's my manifest? So for the actual connecting, you only need the Bluetooth permission. But to do the scan we saw on the slides, you need the Bluetooth admin permission. You can connect, though, to a device if you know the MAC address directly. But then again, if you look at the devices, they don't print their MAC addresses, and you don't want your users to get the MAC addresses. And the real problem is that Bluetooth admin gives you rights to shut down and start Bluetooth as well. So if you have apps that like do useful things with Bluetooth Low Energy, don't worry that they can shut down Bluetooth and restart it. They have to, otherwise they wouldn't be able to connect. I would really say this is a problem in the platform. And again, I don't think the Google guys really thought about this, because it's only the scanning for devices that requires the admin. I don't want to shut down Bluetooth, like I don't care. Yeah. Also some things that you find out when you do this. More questions? Yes, just.
Another one. So, what about encryption? So, is there some kind of pairing, and afterwards is the connection somehow encrypted or authenticated? And is that optional? If so, and how does that affect battery?
So by default, I guess there's no encryption. As you see in the code, I don't ever get asked to encrypt data. If you want to do encryption, you probably want to rely that your descriptors, like the data is encrypted by, like your byte stream is encrypted by yourself. I actually really don't know if there is something in the standard of Bluetooth Low Energy that has encryption. I think at one point I saw something, but I wouldn't really rely on it. And if you want to do security or like secure connections, you probably want to just encrypt your byte stream and that's it. It's generally made. It's specifically also made for these types of communications. And I don't know if you want to encrypt your heartbeat. It's like it's.
Fake it, and it's about 10 meters range, I think. So
Yeah. Well, again, what do you want to achieve? I mean. Yeah, it's not really something that was, at least from the main use case, was designed to be secure. But I would assume that there is some encryption at some point. I haven't found it out. If you find something, please make a pull request for a security slide. Other questions? Also Bluetooth Low Energy maybe.
Is there some kind of pairing, or can anybody?
Again, you've seen it. If you, and again, I'm pretty lazy at the moment. I just take the first device that pretends to be a heart rate monitor, which is now my Mac. That's it. Like initially, if you don't know the MAC address of the device that you want to connect to, but then again, the MAC address is probably easy fakeable as well. There's no way you can actually know that the device you're talking to is the device that you have in your hand. Like if I stand next to you, if you want to connect to your heartbeat sensor on your chest, but I'm doing the same thing, then chances are you connect to my fake heartbeat sensor, and then, I don't know, weird things might happen. So you've really seen everything, like connecting to it. It's that easy. There's nothing really more to it. And then if you really want to do security things, you probably want to have, like what they do, if you want to have, you have one characteristic that you write a password to, and then other functionality and other characteristics get unlocked. So this is what you will have to do on regarding security. But then probably the password transmission over the air is not encrypted, so it's not really safe anyways. It gives you some sort of encryption. But then again, Bluetooth Low Energy is just the transmission. Like whatever you implement on the other side, let's say you can have a brute force countermeasure on your device that if you enter the wrong password, you can't log in for another 3 minutes. That might actually help for brute force attacks. But again, what do you want to achieve with security on this? It's not really meant for secure communication, I would say. Maybe something interesting if you want to do server stuff like I do on my Mac to become a heartbeat sensor on Android L. All of this will become available on Android devices as well. And then you can also connect two Android devices to each other. Right now that is not possible. The only thing that's possible with Android 4.3 and 4 is connecting to a peripheral. So that's all you can do. You can't have two devices talk to each other. But with L, it will be possible. Other questions? Well then, thank you.